Here we go. Okay, so today what we're going to do is we're going to talk about substitution and evaluating. Okay, we're dealing with algebraic expressions. How do I know that something is algebraic?
It has numbers in it.
Not numbers, but what? Letters in it. Yeah, variables, right. It has variables in it. There you go. Okay, and they're expressions and not equations because expressions do not have what kind of symbol?
An equal sign.
An equal symbol. There you go, right? Equations do, but expressions do not. So we're going to talk a little bit about substituting. Equations have equal symbols, but expressions do not. Right, there you go. All right, so what we're going to do is we're going to talk about substituting and evaluating. These two things always go together. And if you think about it, you already know what substitution is, right?
No.
Sure you do. If you're going to substitute something, what does that mean you're doing?
You are getting rid of it and then putting something back in its place.
You're putting something in its place, like having a substitute teacher, right? You have somebody standing in place of the teacher. So what we're doing here is when you're substituting, that simply means to replace the variable or variables, because you can have more than one, right? With a given value. And notice I said value and not number or constant, because you can substitute in another variable. It's not going to probably happen to you just yet, but you need to remember that you can anytime you're substituting, whatever they tell you to substitute, that's what you'll replace the variable with. Okay? Now there is a rule for this. Always, and you'll see it always, and you need to do it always, because you need to keep the operations true. You never replace a variable
with a constant.
No, that's usually what you do, replace it with. Without using a bracket.
Oh.
So go ahead and write that down, and then I'll show you what I mean. Never replace a variable without using a bracket. So don't do any substitution without including a bracket. And the reason for that is you have to keep the operation true. It has to still say the same thing after you've replaced it. So for example, say you have 2x, right? And I tell you that x is equal to 6. That means that in place of that x, I want you to put what number? A 6. That's all substitution does, okay? But, so can I just do that?
Oh, I see. Okay.
Right? Because that is a totally wrong number, right? That's just 26. Exactly, because remember that 2x literally means 2 times x. So I don't want you to write the multiplication symbol, because remember in algebra we're lazy. We don't write symbols if we don't have to. But instead what you'll do is you'll always replace any variables when you do the substitution. You'll always use brackets. Because if you have a number right in front of a bracket, remember that's one of the ways we wrote multiplication. So now, so that's what substitution is. Now, evaluation simply means do the math after you've done the substitution. So what math is there to do here?
The brackets, you do it inside the bracket.
So is there anything I can do inside with just a 6? Is there an exponent?
No.
Is there a coefficient?
Yes.
Yeah. So just 2 times 6, which is?
12.
And there you are.
That's cool.
So we substituted and we evaluated. Okay? So let's go ahead and write a definition for evaluate. Oops. Evaluate simply means to simplify. And remember, simplify is that all-purpose word that means do the math. Right? Whatever's there, you do. You work it out. Okay? So, just means do the math.
But can I please ask you a question?
Yes?
What is half math? What do we actually use it for?
Oh, well, everything you've ever done has got math in it. You couldn't be wearing those clothes if somebody didn't know how big to make them, right? Or that's math. You think this just came out of nowhere? Right?
Yeah, but not in algebra. Like that.
Okay, so substitute. Never substitute without putting things in a what? Bracket. And then evaluate simply means simplify, which means do the math. Right? So what we're going to do is we're going to go to our Education Perfect and just kind of look at some of these. All right, so before we learned how to simplify algebraic expressions, right? Write them as small as you possibly can. Combining like terms, getting rid of brackets, etc. So today what we're going to do is we're going to just look at some examples. We've talked about substitution and evaluation, so we're just going to look at some examples of how to do that. So look at this one. So here's our example. It says a plumber charges $70 an hour and a call-out fee of $40. Okay? So every hour that he's there, he's going to charge how much?
40.
70, right? And then he's going to charge you $40 just for coming to your house in the first place, right? So, is a plumber always going to be there the same number of hours? No, depends on the job, right? So that is going to vary. The number of hours is going to vary. So in this case, our variable is the number of hours. And so if you look, they called it what?
V.
Well,
No, H.
H for hours, right? So we can make an algebraic expression from that by thinking of that the cost is going to equal $70 times the number of hours that he's there plus the $40 that he charges just for coming. All right, so does everybody see where all of that came from?
Yes.
And that gives us an expression that will allow us to find the cost no matter how long the plumber was at the house, right? So in this example, what we want to do is we want to find out how much is it going to cost if he spends 5 hours. So in other words, when H is 5, right? So all we need to do that is simply substitute in H. Instead of H, we'll put it as what? As 5.
You have to remember to put the brackets.
Exactly. So substituting H for 5, and you'll look at what they've done, right? What do you notice about what they did with the 5? It's in a bracket. Good. Now, they did one thing that I don't agree with, and you know what that is already. I don't like that X, right? Because if you have 70 and bracket 5 plus 40, it means the same thing without having to write more stuff, right? And remember, in algebra, we write as little as we possibly can. So now we can evaluate that. What part do I have to deal with first?
The bracket.
The bracket. So I'm not going to work with the 40, so I'm just going to bring that down. And there's nothing I can do inside the bracket. There's no exponent, but there is a coefficient. Excellent. Coefficient just means the multiplier, right? So I need to take 70 times 5, which is going to give me what? 350. 350. Good. And now I can just finish it off by taking 350 plus 40, which is 390. Right? So substituting the value in and then just doing the math. That's called evaluating. Okay? So here's what I want you to do. Pull out a piece of paper. If you got one. If you don't have one, you need one. Or you can do it on your computer. That's fine. What I want you to do is I want you to tell me how much it would cost if the plumber was there for 3.5 hours.
3.5? Can we use a calculator?
Yes, you can use a calculator, but
Actually, I'll use my brain.
you could use your brain too. But either way. Go. You've got 1 minute.
No.
Yeah.
But I don't have the page. Wait, I
don't
have the task. You said 3.5?
It's right on the thing. Look up there.
Okay. Actually.
So if he was there for 3.5 hours, 3.5 hours, how much would it cost? You have your formula, so all you have to do is substitute.
What is substitution? Oh,
Do we have to solve it then?
Of course.
Okay.
How much would the cost be for that? Substitute and then evaluate.
I wasn't putting my hand.
Okay. Right, so we've got 70 times our value plus the 40.
Yeah.
Right, so there's the substitution. Okay, so...
And then, can I keep going?
Oh, it's all right, she's got it.
And then it was 245 plus 40.
So you multiplied the 70 times the 3.5,
Yeah.
and you got what?
245. No, 285. No, 245 plus 40. Oh, right.
245, and then plus the 40, which gives you
285.
285.
Yay! I got it right. Same.
And remember, don't forget your units. We forgot our units too. Dollars. Okay? How does that look?
Good.
Yeah?
Because there's a 5 and I meant for 4.
All right. So, you look at this one. Evaluate 2x minus 1 where x is equal to 3. All you need to do is replace the x with the 3 in a bracket and do the math. So you see that makes it 2 times 3, which is 6, minus the 1, which gives us 5. Right? Pretty simple. Good deal. Okay. Well, there's one other small thing here that we want to talk about in this section, and that's another phrase that you need to know in order to be able to be very efficient at your algebra, and that is the phrase equivalent.
Ooh, I know what that means.
Okay? If something is equivalent, what's the root word you think of equivalent? Equal. Exactly. So if two things are equivalent, that's the same thing as saying that they're equal.
Which is the same thing as the equal sign.
Okay? So if two things are equivalent, that means they're the same. So for example, if I have 1 plus x, that's the same thing as saying x plus 1, isn't it? Because you can do addition in any order. Okay? So, as long as two things are equal to each other, they're considered to be equivalent. But things might not look the same at first, but they can be the same after you simplify them. So you may have to simplify something first in order to be able to determine if they're equivalent. Okay? So let's look at an example here.
How do I spell equivalent?
It's right there in red on the board there. So here I have two expressions, two algebraic expressions. I have 2x plus x minus y and 3x plus y minus 2y. Do you think those two things are equivalent? It's hard to tell right now, it doesn't, because they don't look alike. But what I can do, though, come on guys, settle. But what I can do is I can first simplify them, because if you'll notice, both of them have like terms in them. So let's begin by simplifying those. Okay, so if I have 2x plus x minus y, notice that I have two x terms. So those are considered to be, what are they called?
Like terms.
Like terms, so therefore they can be
Combined.
There we go. So what is 2x's plus another x going to give me?
3x.
3x's, good. And then the minus y just comes down. Can I combine an x term and a y term?
No.
No, good. So that one's simplified. Let's look at the other one. We have 3x plus y minus 2y. Do I have any like terms there?
Yes.
What are like?
Y.
The y's. Okay, so that gives me 3x. And I have plus y minus 2y's, right?
That's just y.
Well, what kind of y?
Minus 1y.
A minus 1y or a minus y, right, good. Because the signs are different, right? That's the same as positive 1 minus 2.
Oh.
So that's going to give us a negative 1y or just plain y. Okay. Now what do you notice? That after we've simplified them, are they identical?
Yes.
Therefore, they are also called what? Equivalent.
Oh, I see.
Right? They didn't look like it at first, but after we simplified them, than they were.
So why would people have to make them so complicated?
Well, sometimes life is complicated.
But why?